Hello everyone. So we are today here to solve this lead code problem number 2444. It's count sub-arrays with fixed bounds. So let's read the description. Let's try to come up with a solution. So we have been given an integer array nums and two integers min k and max k. It's like this. And what we have to do is a fixed bound subarray of num is a subarray that satisfies the following conditions. Okay, minimum value in the subarray is equal to min k, okay, and maximum value of subarray is equal to max k. Okay, so we have to return the number of fixed bound subarrays. Let's look at the example. Uh, so we have been given 135,275 and min k is given as 1, max k is given as 5 and the output is 2. Why? Because the fixed bound subarrays are 135, the min of this subarray is 1 and max of this subarray is 5, and here as well min of this subarray is 1, max is 5. So if you look at all the subarrays of this array, you will only find these two. So that's why the output is given as 2. So let's try to think it through and come up with a solution. I think one way of doing it could be we can find all the subarrays. So what we can do is find all subarrays and then um, for all subarrays, check which subarrays um, satisfy this condition. So satisfy given condition. So we can check that, and to find all subarrays, I think we can do it in an optimized manner. We can do it in O of n square. So this is going to be O of n raised to power 2. Let's look at the constraint and see if we can solve it in O(n) square or not. Okay, so the constraints are a little bit tight here, and I think this O(n) square solution is going to time out. Let's try to implement it, and if it works, then we are good. Otherwise, we will have to try to come up with a better solution. So let's um, write a for loop. Let I equals to 0, I is less than, let const n equals to nums dot length and I plus plus. And then this will be our starting point, and then we take another for loop that will be from j equals to I to j is less than n and j plus plus. So now what we have to do is we have to build our subarray from here. Let subarray equals to this and subarray dot push nums j. So this is our subarray. Let's take a result, and what we can do is I think we don't need this, and instead we can simply maintain our min so far. So this will be min so far equals to let's take it as a very big positive number, infinity, and max so far. Let's take it as negative infinity. So if um, so what we have to do is we have to check if our subarray satisfy this condition. So we have to check if min so far. Actually, let's first do this math.min min so far for nums of j, and same goes for max so far and max. So this will find our min and max so far, and then what we can do is we don't need it, so let's remove it simply. What we can do is we can check if uh, min so far equals min k and this is equals to min k and max so far equals to max k. So what we do is we do result plus plus, and in the end we return result. So what it will do is it will maintain a min and a max, and if that min and max is equals to min k and max k for any sub array, it will simply increment the result. So let's try to simply dry run for a small input. Let's do it for this with min k and max k equals to this. So it will start from 1, and then it will go in here, set min as 1. So min will be 1, max will also be 1, and then it will go to next. So now it will check in these two. So max will be 3, still no matches. Then it will move to 5. This will be like this. Now this is a match. So result plus plus. Then we move here. So again, max is 5, min is 1. So we add result plus plus. Again, max is 7. So we don't do anything. So here as well, max is 7. We don't do anything. So this is our O(n) square solution. Let's try to run and see. So it got accepted. Let's try to submit it. It's taking too long. I think it's going to get a TLE, time limit exceeded, and we might have to improve our solution since the constraints are a bit too tight. Yeah, right. It's a time limit exceeded. Okay. One thing that comes to my mind when solving such kind of problems that asks us to have this kind of thing like maintaining a boundary kind of thing in a solution. What we can do is uh, we can like use a running some kind of solution, more like a prefix sum. So let's try to think it um, for this example. Uh, so currently what we are doing is we are starting from here and checking for all the subarrays that start from this point. Let's think if we can come up with a solution. So this one max is 5. So minimum was this, and here that is where we had found one solution of a subarray. Okay, I think one way of doing it could be like this. We like instead of finding all sub arrays that start at this index, what we can do is we can find all the sub arrays that end at this index, and that way we can use it as a pivot point and like check uh, min and max from this point and see if we can come up with a solution. Okay, so I think what we can do is we can instead of using this O(n) square approach, we can use something like a two pointer kind of approach. What we can do is we can keep track of minimum index initially we can set it to -1, same for max index and out of bound. So OB index, that's also -1. And when we come across a number that is equals to min k, we update our min I to be I, and same for if it's equals to max k, then we set max I, and if nums I is out of bound, like smaller than min I, min k, or nums I is greater than max k, we set OBI equals to um, I. Okay, and then what we can do is we can find the smaller of these. Let smaller equals to math dot min of min I or max I, and then we can simply like reduce this out of bound uh, values subarrays that end at this index, and we can simply add our result to this math dot max of 0 or math dot this and smaller minus OBI. Okay, let's try to run it. Yeah, that worked. Let's try to submit. Okay, it got accepted. Nice. So that's all for today. See you tomorrow. Bye bye.